Hello friends, my name is Arun Kishore Voleti and welcome to my channel Learn Deep. We are currently in Python playlist. In my previous videos, I clearly explained you what are the basic concepts which are required to write a program in Python. So from this video, I will take one or two examples for a program based on the time I have. Like I want to keep these videos as short as possible. So I'll take one or two programs and I'll clearly explain what is the topic behind the program, how to solve the program, and finally I'll write the code for program. So without wasting any time, let's get started. And in this video, the program which I want to tell you is to find an even number or odd number. So the user will enter a number and I am supposed to find whether the number is even or odd, right? So what is the basic idea which will come to our mind when we see this program? The basic idea. So the basic idea is we'll just divide it by 2. If it is exactly divisible by 2, then the number is even number. If it is not exactly divisible by 2, then the number is odd number. So just write a program for this. I'll take number as input. So num is equals to int of input of. So I'm taking number as input from the user and I'll write an if condition. So I'm going to write number exactly divisible by 2, it is even. So how I am going to check whether it is exactly divisible by 2 or not? If any number is exactly divisible by 2, then the remainder is 0. So if the remainder is 0, I am going to print it is an even number. Right? What would be the else part? The remainder is not equal to 0. If the remainder is not equal to 0, I am going to print it as an odd number. Right? So let's check this. I'll give input as a 10. I'm going to get even number. If the input is 12, so 11, I'm going to get odd number. So we are finished with one step. We came to know how to write a program to find whether a number is even or not. So as I discussed earlier, any number which is exactly divisible by 2 will definitely give a remainder 0. What if the number is not exactly divisible by 2? What would be the remainder? So let's take the case of 5. 5 when divided by 2 will give a remainder of 1. 7 also gives a remainder of 1. 9 also gives a remainder of 1. So what is your conclusion now? Any odd number which when divided by 2 will give remainder 1. So instead of writing the remainder is equal to 0, I'll write the remainder is equal to 1 and I'll say the remainder is equal to 1, it's an odd number. If the remainder is not equal to 1 in the else part, I will say it as an even number. So let's check this. Again I'll give input. Okay, so we got the output, right? So this is the most basic approach everyone will follow. So here comes the question. Nearly 200 to 300 people attended an interview where each person got the same program to find whether a number is even or odd. If all 300 people write the same program, on what basis will the interviewer shortlist the people? So they'll check for that person who write this program in a different approach. So for this reason, we need to find a solid approach which can give the same output but will not take this logic, right? So instead of writing number percentage to double equal to 0 or double equal to 1 equating with 0 and saying it as even equating with 1 saying it as odd, we have to employ a new approach. So what would be the new logic? I'll tell you. Using arithmetic operators only we can find whether a number is even or odd. But instead of using modular division, we can directly use division operation to find even or odd. Actually, we are also performing division here, but we are checking the remainder. Now, instead of checking the remainder, we are going to check what is the value of division. If I say, I'll take an odd number. So, 11 divided by 2 will give 5.5. If I say, what is the integer value of 11 division by 2? It is equal to 5. In Python, I have floor division operation, which is very much similar to dividing normally and typecasting with int. So instead of writing like this, I can directly like 11 floor division 2, which is equal to 5. So if if I take any even number and if I perform a normal division and I perform a floor division, if I equate the both results, I'm going to get 2. And the same for an odd number, if I equate both the results, then I'm going to get false. So instead of checking about the remainder, what I'll do, I'll directly check the result of division. The result of division is equal. In case of normal division and floor division, the number is even. If they are not equal, then the number is odd. So what exactly floor division is going to do? Floor division, no matter what is the precision value, it is going to convert, or it is going to floor. Floor in the sense, in our house, the upper part is called as ceiling and the lower part is called as floor, right? So there is a number which is in between ceiling and floor. Always floor division will decrease the value and makes the value round to the nearest smallest integer to it. So if the value is 2.9999 also, the floor division will convert the value to 2. The name itself indicates it is going to floor, it is going to round down the value. Clear? So let's change the logic. Okay, I'll keep it as odd number and even number only. So instead of writing number modulo division 2, I'll write number divided by 2 is equal to number when floor division by 2 or not. If it is equal, then the number is even number. If it is not equal, then the number is odd number, right? Okay. So I'll run this program. I'll give 10 as an input and I'm going to get even number. And if I give any odd number, like if I give 11, I'm going to get it as odd number. So what is the logic which we employed right now? Instead of seeing what is the remainder after division operation, I'm going to validate the direct result of the division, right? So let us extend this logic. What if I write 2 into 10 divided by 2? So I'm going to do floor division of 10 with 2 and I'm again multiplying it with 2. My result is 10 itself. So what if I write the same command and I'm giving any odd number? So I'm taking 10, I'm doing floor division with 2, and for the result I am again multiplying it with 2. I am going to get the same number which I have taken earlier. But in the case of odd number, when I am doing floor division, the precision value is discarded. So instead of 5.5, I am going to get 5 as a result of this operation. And 5 into 2 is equal to 10, which is clearly not equals to 11. So instead of equating it with another division result, like I am going to use normal division and floor division and I am going to equate these two values. Instead of doing that, we can also do like this. I will only perform floor division operation and I will check whether when I multiply this floor division result with 2, I am getting the number which I have taken earlier or not, right? So if I do like this and if I give even number as an input, so I will enter 10, I'm going to get even number, and if I enter any other odd number like 11, I'm going to get odd number, right? So far we have discussed 3 logics, right? We are going to apply modulo division and we are going to check the remainder. If the remainder is 0, it is even. If the remainder is odd, sorry, if the remainder is 1, it is odd. And the second approach which we followed is we are going to validate the results of 2 divisions like normal division and floor division. If both are equal, then the number is even. If both are not equal, then the number is odd. And the third approach which we are following is we are going to apply floor division on the number. Again, we are going to multiply the number with 2. After division, after dividing it with 2, if we multiply again it with 2, if the number is equal to the original number which we have taken, it is even, else it is an odd number. So far what we have done, we have kept the number as it is. So let's think out of the box. How we can solve the problem of even or odd without directly using these arithmetic operations. So question is given like this. Don't use any arithmetic operation but still find whether a number is even or odd. So what else we can use? The immediate thing which we have to get into our mind is we can also use bitwise operations. So I'll close this editor because many programs were written in this only. So I'll take a new editor and I'll tell you one thing. We have one function called as bin, which is going to return a binary value of any decimal. So I'll return the binary value of 10, and I'll also take the binary value of 11. I'll take few more numbers, like I'll take 12, 13, 14 and 15 also. So after seeing this, just pause the video for a while. Just analyze what is similar these numbers, right? So here are the results of 11, 12, 13, 14 and 15, their binary form. So pause this video, have a look on this and say what is the conclusion which you drawn by seeing these results. Hope everyone got that point, right? If you take any even number, the ones digit, like the encoding will be like this, right? 2 power 0, 2 power 1, 2 square, 2 cube, 8 to 4 on format. So the only odd number which you encounter in this binary format is 1, and the ones position is the last position, as it is 2 power 0. So for any odd number, this ones position must be enabled. It must have 1. And for every even number, the value at its least significant bit is 0. The reason is 1 is the only odd number in our code, like 2 power 0, 2 power 1, so on to 2 power n. The only odd number which we encounter is 2 power 0. So for every odd number, we have to make use of 2 power 0, right? I'll show you. So if you are supposed to try the binary codes, I'll just write for 16. So for 0 it is 000, for 1 it is 001, for 2 it is 010, for 3 011, 100, okay, 1 101, 110, 111, similarly. So for every odd number I am going to have 1 here. For every even number I am going to have 0 in the least significant bit. This is what the conclusion which we got by seeing many values in their binary format. So by using this, can we find whether a number is even or odd? Yes, we can find. What I'll do is, I'll take any binary number. So I'll write something like this. So by seeing this, we can clearly say this is an even number, because the least significant bit we have is 0, and the least significant bit is 0. It is an even number, right? So to find this, what I am going to do is, I'll perform bitwise AND operation with 1. So I'm going to perform bitwise AND operation with 1. So as the least significant bit of any even number is 0, 0 and 1, the AND operation will result in 0. So I'll take a number and I'll perform bitwise AND operation with 1. If the result is 0, then it is even number. And what if the result is 1? Let us take some number, right? I'll take this number and I'll again perform bitwise AND operation with 1. Here the least significant bits in these both numbers is 1, and the AND operation between these two numbers will result in 1 itself. So for every odd number, the bitwise AND operation with 1 will definitely result 1. So let's check this. Let's directly write the code itself. So instead of writing the if condition like this, what I can do, I can simply take bitwise AND operation of the number with 1. If the result is 0, then it is even number. If the result is 1, then it is odd number. And I'll tell you one thing. I'll take 10 as my number and I'll do bitwise AND operation with it. So the result is 0. 0 in the sense false. So what is the result if the number is even? If the number is even, the result is 0. And if of 0 will never be executed and it will directly go to else part. So if you write this condition, either you have to write like this, like the result is equal to 0, or you have to write not, because it is going to convert the 0 to 1. When the if condition will get 1 if the result is 0. If the result is 0, then the number is even, else the number is odd. If you don't want to do all this stuff, you can simply write condition as number bitwise AND operation with 1, and you can simply change even to odd and odd to even. Clear? So let's check this and see what would be the result. I'll run this program and I'll give some even number as input, and I'm getting it as even number. And if I give odd number as input, I'm going to get it as odd number. So what is our fourth approach? We are going to do bitwise AND operation with 1. For every even number, the least significant bit will be 0 always. So the AND operation will result 0. And for every odd number, the least significant bit always is 1. And the AND operation with 1 will definitely result in 1. So by using this condition, we can say whether a number is even or odd. So now let's think about the basic process which we employed in our previous methods. Like we are going to divide the number with 2, and again we are going to multiply the number with 2. We need to get the same result as we are getting earlier. So in binary format, we have two operations like left shift and right shift. So I'll take 0, 1, 0 as my number, and I'll perform left shift operation. Okay. I'm getting like this. I don't know why. So I have to write like this. I'm not supposed to write 0 in front. So what I'm going to do, I'm going to perform left shift operation. So take any number. I'll take 4 and I'll perform left shift. It is going to become 8. 110 is going to become 220. So what is the conclusion which we got by seeing this? Whenever you perform left shift operation, it will yield double of that number. Similarly, if I take 8 and I perform right shift operation, I'm going to get half of the number. Clear? So what exactly we are doing is, we came to know one conclusion that if we perform left shift, the result will be double of that number. If you perform right shift, the number will be half of that number. So while taking even numbers, the left shift and the right shift will not show any problem. But for odd numbers, left shift will not show any problem, but the right shift is going to show a problem which we encountered in floor division, right? If I take 11 and I perform right shift operation, I'm going to get 5 instead of 5.5. The same result I'm going to get when I do it. So what I'll do is, I'll take any odd number, I'll perform left shift, and again I'll perform right shift. So the result will never be equal to the number which I have taken earlier. In case of even numbers, if I do the same thing, right, I'm going to get the same result, right? So what exactly I'm going to do? I'm going to follow the same old technique which I followed while using arithmetic operations. I'm going to divide the number by 2. I'm going to multiply the result with 2 itself. If it is equal to the original number I have taken, the number is even, else it is odd. So the same condition which I am going to write right now. So what I will do, I will take a number. For changing this, I will change this from odd, even and even to odd, right? So I am going to take a number. First, I will perform right shift operation with 1 bit. The 1 indicates number of bits to be displaced. I am going to perform right shift operation with just 1 bit. So this operation will result in half of the value. And again I am going to double the value. If the doubled value is equal to the number, then probably my number is even, else my number is odd. So just let's check this. I'm going to give the number as an input. I'm going to get even. And for the odd number as input, I'll get odd for sure. So what exactly we have done in this video? We have discussed 5 basic approaches of solving a program to find whether a number is even or odd, right? What is the first and the basic approach which we got? We are going to take, let me show this. So the first approach is we are going to take a number and we are going to apply modular division. If the result is equal to 0, it is even, else the number is odd, right? So for odd number, the modular division will result in 1, and for even number, the modular division will result in 0. So based on this approach, we find that whether a number is even or odd. So what is the second approach which we followed? Instead of finding the remainder, we are directly going to equate the division result. Okay, division result with 2. We are going to equate two division results like normal division and floor division using 2 only. If the number is equal, then it is a even number. If the results are not equal, then the number is odd number, right? This is what our second approach is. And what is our third approach? Our third approach is instead of equating the division results, we are going to multiply the same number with 2 itself. So I am going to multiply the number with 2. What number? The result of division operation, result of floor division operation. We are going to multiply it with 2. And we are seeing whether it is equal to the original number which we have taken or not. If it is false, then the number is odd number, and if it is true, then the number is even number, right? This is what our third approach is. What is our fourth approach? Instead of using arithmetic operators, we came to use bitwise operators. Like I am going to perform bitwise AND operation with 1. If I am performing bitwise AND operation with 1, the result will be 0 in the case of even number, and the result will be 0 in the case of odd number. So the result will be 1 in the case of odd number, right? So bitwise AND operation will result in 0 if the number is even. It will returns 1 if the number is odd. This is our fourth approach. And again, the fifth approach is very much similar to the approach or third approach. We are going to multiply the number by, so divide the number by 2, and then we are going to multiply the number by 2. So in bitwise operators, left shift will result in multiplication with 2 and right shift will result in division with 2. So first I am going to take a number. Let us say my number is 11, and I am going to right shift the number by 1 bit. This operation will result in half of that number. So 11 by 2. Here it is going to perform floor division only because there will be no binary value for points, right? Binary values will exist only for integers. So 11 by 2 or 10 by 2, it will be 5 only while doing right shift operation. So again I am going to left shift this with 1 bit. If it is equal to the original number which I have taken, then the number is even number. If it is not equal to the original number which I have taken, then it is odd number. So these are the 5 basic approaches which we are using to find whether a number is even or odd. So that's all for this video. In my next videos, I will discuss few more examples which are based on conditional statements. After dealing few examples on conditional statements, I will also deal basic examples which may include loops also. And do remember, I am not using any data structures, like I am not using list or tuple or dictionaries. I will deal with those concepts later. But for these videos, I will only focus on conditional statements and loops. So meet you in my next video. If you like this video, do like it, comment, and subscribe my channel if you are new to this channel. And if you didn't understand any point why I am writing AND or how I am writing if condition, please watch my previous videos in which I have clearly covered all these topics. Thank you.